Okay, example 3, for each rectangular equation, give the equivalent polar equation and sketch its graph. So notice how they're giving it to us in rectangular, which means x and y, but they want polar, which means r and theta. It's the same thing as what we've been doing. They're wanting us to convert. Okay? They're wanting us to convert. I want to be able to see polar. And so if you think about the conversion, I know that y is equivalent to r sine theta. And I know that x is equivalent to r cosine theta. So I just do a conversion. I use the same exact formulas that I've been using, but I do a conversion so that I can see an r and a theta. Now, if I wanted to graph those, I'm going to need to isolate the r. If you wanted to plug that in on your calculators, you'd want to isolate r. And so that's what we'll do. We would subtract this over so we can get the r's at least on the same side. We have r sine theta minus r cosine theta equals -3. You have to do a little bit of factoring. I see both of those expressions right there have an r in it. So it's like we take a GCF, a common factor of r, out. And that's really the hard part, I think. That's the trick to this. Factor out r so you can get it iso. We've got r by itself now. Well, I guess if I divide both sides by this, I will. We're going to divide both sides by sine theta minus cosine theta. So r will equal -3 over sine theta minus cosine theta. Give the equivalent polar equation. Good, got it. And sketch its graph. So let's use the calculator to sketch its graph. Go to Desmos. We want r equals -3 divided by cosine theta minus sine theta. So you can see it's a line. We knew it was a line. Remember, if you look at the original equation, it said y equals x minus 3. Y equals x minus 3. Oh, wait a minute. I didn't type that in right, did I? It's sine is it sine theta minus cosine theta? Is that the same thing? Oh. That'll do it. Okay. That looks a lot more like what I wanted. I wanted something that looked like x minus 3. If you think about what we would have done in Algebra 1 class, start at -3, go up 1 over 1, up 1 over 1. That's what this is going to look like. So maybe I zoom in and look for intercepts. I think the easiest way to graph this is going to be to look for intercepts. But I can see that it crosses at -3 on the y-axis and -3 on the x-axis. Or, really, you can't really say about x and y. You'd be looking at a distance of 3 at 0 degrees and a distance of 3 at 270 degrees. So it's going to have a point at 3, 0 and a point at 3, 270. It's going to be a line through there. Let's go ahead and look at Part B. Part B, we're doing the same thing. Well, notice x squared plus y squared. X squared plus y squared is equal to r squared. We've got a formula for that. So r squared equals 4. If you took the square root of both sides, you're going to get to r equals 2. You can say plus or minus, but the minus doesn't totally make sense here when we're talking about a radius. Okay? This says radius equals 2. What's that shape? That's a circle. That's a circle with radius 2, and so a circle is really easy to draw with this paper. Just trace a circle with radius 2. And that's it.